we're going to solve absolute value of x plus 1 plus 2 less than 5 and write the solutions on a number line and also write an interval notation. The solution to this problem and similar problem like this are under these two links. You can go and check that. You want to isolate the absolute value of the first step. So I want to subtract 2 from both sides of the inequality. All right, so let's do that. We get absolute value of x plus 1 is less than 5 minus 2, which is equal to 3. Now I need to translate this into inequality without absolute value. So I'm going to go back to the fact that if absolute value of x is less than the number a, I want to know what that really means. Can somebody tell me what that means? If this is 0, if this is a, and this is minus a, then I have absolute value of x is less than a, what that means. So in other words, it means all the numbers, the solution would be all the numbers that are less than a units away from 0. So that's the word for it. Less than a unit. What are the numbers less than a units from the 0? So it would be all the numbers. All these numbers are less than a units away from 0. And to the left of 0, also these numbers would be less than a units away from 0. Okay? If I change this a to 3, means absolute value of x is less than 3, means all the numbers that are less than 3 units away from 0. What are the numbers less than 3 units from 0? Would be 1, 2, right? And negative 1, negative 2. So that's what it means. So if I want to write this, I can write this as all the numbers are in between negative a and a. So look what I'm doing here. I'm translating this inequality, which has absolute value in it, into this inequality without absolute value. And that's how I do it. I have to kind of think of this as a distance of the number to 0. So absolute value of x is less than a means all the numbers that are less than a units away from 0. So in this case, now I need to translate this, which is more similar to this, as you see, into the solution would be all the numbers are in between. My a here is 3, so it would be negative 3 and 3. But my x is this expression here now. Instead of x, I'm going to write x plus 1. So mathematically, this expression here and this expression is identical. So as mathematically, this expression and this expression were identical. The only difference here is, here I had inequality with absolute value in it. Now I don't. I have an inequality without absolute value, which I can solve for. Can somebody tell me what would be the next step here? How do you solve for x? What do you have to do? How do you isolate x? Subtract minus 1 from each side of this inequality. So there we get negative 4. Here would be x. And that would be 3 minus 1, which is equal to 2. So my graph for this inequality would be all the numbers that are in between negative 4. So my a turns out to be negative 4 and 2. Okay, I'm going to use the parentheses because the endpoints are not included. That would be my graph. How do you write this in interval notation? How do you write this in interval notation? Parentheses. Negative 4, comma, 2, parentheses. Yeah. We're using parentheses because the endpoints are not included. If it says equal to, then we would use brackets. So this would be my interval notation. This would be my graph. And again, I needed to know this fact here to solve for this problem. Okay, the question is, when we have an absolute value inequality, like absolute value of x is equal to 2, or absolute value of x is greater than 2, or absolute value of x is less than 2. So let's see what these mean. if I graph the solution for all these three, I can look at the solutions here, and then I'm going to write the solutions in interval notation. So if this is 0, the first one, absolute value of x is equal to 2, means find all the numbers that are exactly 2 units away from 0. Okay? Can you tell me, you asked this question, can you tell me what are the numbers that are exactly 2 units away from 0? How many numbers do you have that are exactly 2 units away from 0? Only 2, right? Those numbers are 2 right here and -2. These two numbers are exactly 2 units away from 0. So if I measure from here to here is 2 units, right? And from here to here is 2 units. So the solution to that, if I want to write it without absolute value, would be x is equal to 2 or x is equal to -2. We get two solutions. I use or means union because I want to include both of these solutions. Now, the next one says absolute value of x is greater than 2. We're talking about give me all the numbers that are larger than 2 units away from 0. That's what you're asking. What are the numbers that are larger than 2 units away from 0? If this is 2, all the numbers to the right of 2 would be larger than 2 units away from 0, right? Like 3. If I measure 3 from 0, would be larger than 2 units, right? On the other side, also, all the numbers to the left of -2, if I measure them, would be in distance larger than 2 units away from 0. So from here to here is larger than 2. Therefore, the solutions will be to the right of 2 and left of -2. However, when I say absolute value of x is less than 2, you're talking about all the numbers that are less than 2 units away from 0. What are the numbers that are less than 2 units away from 0? All the number between -2 and 2. So that's why the solutions would be in between. So you ask which is which. How would I know if the solution would be between those two numbers or outside those numbers? That's how you have to look at them. Right, the signs, exactly. Well, you can ask yourself that how many numbers that you can find that are larger than 2 units away from 0, and look for those numbers in the number line. When it says greater than 2, means we're looking for the numbers that are larger than, because absolute value relates to the distance of the number to 0. So when we're talking about the absolute value of x is greater than 2, we're going to rephrase that question, say, what are the numbers that are larger than 2 units away from 0? And just if you look at the number line, you can see easily that all the numbers to the right of 2 and all the numbers to the left of 2 are larger than 2 units away from 0. So you don't have to memorize anything. You don't have to memorize if it's larger to the outside or less to the inside. You just have to just rephrase the question for yourself that when somebody asks you, what is absolute value of x is less than 2, okay, what that means is, give me all the numbers that are less than 2 units away from 0. And look at the number line. These are the numbers that are less than 2 units away from 0. And once you establish that, then you can easily write that in interval notation or any notation you like. This means all the numbers that are in between -2 and 2. So if I want to write this in interval notation, I would use the parentheses -2, comma 2. And this one would be all the number to the right of 2, all the number greater than 2, and all the numbers that are less than -2. If I want to write in interval notation, would be all the number from -infinity, comma -2. I'm using parentheses because the endpoints are not included. If it is, then I have to use a bracket. And then union that with all the numbers from 2, comma, positive infinity or just infinity. So this will be my interval notation. So once again, if somebody asks you, find the absolute value of x is greater than 2, rephrase the question, say, okay, what are the numbers that are larger than 2 units away from 0, and those will be the numbers to the right of 2 and left of -2. If somebody asks you what's the absolute value of x is less than 2, rephrase the question and say, okay, what are the numbers that are less than 2 units away from 0, and that would be all the numbers in between -2 and 2.